Okay, hey, how are you doing? I meant to do this probably during the last few days, but I had to wait because I was sick for a bit. Kind of had a low to medium grade fever yesterday as well for about 20 plus hours. I'm still a bit tired today, but I wanted to record something, so here you go. So if I sound tired, I apologize, but that's why I'm still tired. I guess some graphics primitives today, probably just 2D graphics primitives, such as just drawing a pixel specifically and drawing a line, vertical, horizontal, diagonal lines, maybe like rectangles, triangles, circles, that sort of deal. I don't think I'll get into like a linear gradient or anything. It's just gonna be very basic today, maybe like a solid color fill and then just basic shapes. So I'm probably gonna put these within the kernel in the graphics test command section that I have sort of filled. Well, I don't have it filled out, just resets right now, but it'll go in here. I might make a standalone application for testing these, or for maybe like a sort of paint program, MS Paint style, but worse, of course. If I go into here, I'm probably going to clear the screen and then just draw the examples to the screen. So, and that is, I'm going to change the clear screen function here to take in a color in case we want to clear the screen to a different color. Maybe you guys are tired of the pure white on blue turbo Borland editor style or what have you, old Windows blue screen style. I'm going to change this to take in a color. It's going to be 32-bit because right now we're dealing with ARGB, 32 bits per pixel for our colors. I'll just call it color. So this is simple enough. Instead of setting this to be hard-coded, we'll just set it equal to whatever color we did. You know, same as before. We can just pass in something specifically. What do we want to pass in? I don't know. I'm going to have to change wherever clear screen is called or else this is going to error. But before I do that, I will make probably a little file. We'll put it in include. I'm going to call it graphics. And then I'll make a file in there. Either graphics.h, maybe 2D graphics.h. I think, is there something I can do with the shell like this? And that'll open. There we go. That's pretty handy. So 2D graphics.h. Again, I'm going to put pragma once here. So what was I was going to start with colors. Okay, we can do either like an enum or defines or whatever to hard code some constants here. I'll just do defines because that's right here. It's easy enough. I'll define some colors. Right now we're doing like blue for the screens right now. ARGB is going to be A, R is going to be 0, G is going to be 0, blue is going to be just pure blue, FF. 32-bit ARGB. Colors, okay. We'll make some more down here. We can have, I guess we can do like black and white. That'd be easy enough, right? Black would be all zeros. And then white would be all Fs. Well, except for A, but that should handle, we might handle opacity and things later as well. I'm not too sure how to do alpha blending and whatever other fancy things you can do with colors, so I'm not going to deal with that in this episode. Blue, let's at least define RGB, right? So red would just be, the first two are red, so the first two are going to be F. Green, it's going to be the middle two are going to be F, and then blue again is the last two for R, G, and B. Okay, and then we can define some other things, maybe like yellow or something, which would be red and green, I believe, but without blue. Just to have some, you know, some different colors here. I think purple or violet, or however you want to call it, is going to be red and blue. So red and green make yellow, red and blue would make a purple color. So F's for the red and the blue. Just so we don't get full on 100% contrast all the time, maybe I'll make like dark gray and light gray. So dark gray would be, I don't know, maybe like all twos or something. Something above black, so it's not pure black. But 2, 2, 2, 2, 2, 2, okay. 2, 3, 4, 5, 6, and then we can make maybe a light gray. Which would be, all F's would be white, right? So we'll have a little bit below F. So let's just say D. We'll have 2 away from the bottommost and 2 away from the topmost. Depending on if she sleeps during this whole thing or wakes up or whatnot, I do have a cat, like right there. If you wondered what that blob is. There's a cat that likes to sleep on couches or wherever. So we'll see. We'll see what happens with that one. So we have these colors, so I'll come back to this in a second, but I will at least include this stuff, such as in the kernel. Graphics, I think it was 2D graphics underscore, right? Okay, so everywhere we have clear screen, I mean in all the files, so this and the calculator and the editor, I think are the only things we'll be using this in. We need to pass a color. So since we included the 2D graphics, we can pass blue. It'll look like it normally did. Wherever I just have a plain clear screen, it's probably going to be blue right now, but we could change it to another thing. You can change it on your own to something else, add another color and use it, right? So that's all we're doing in there. Wherever we have it in the calculator, well, I'm going to have to include it in all these too. I'll just do that. Graphics, 2D graphics.h. This needs to be a slash. Okay, so we'll put in blue. And that's all I have in there, simple enough. The editor, I might have it in a few more places, but that's okay. Slash, and we'll include this in the editor, clear screen. You know what I could do is just I'll do the hardcore, the nuclear option. We'll just do it with this. Just change it to here, everywhere, and 6 substitutions. So everywhere we have clear screen, that should be blue now. See if we made any errors so far. I don't think so. I also don't like how much make output I have. I might change that now as well. So, because really all I'm looking for is how big these files are. But let me see if this worked first. So make it should, yeah, it should still clear everything to blue. They really shouldn't take up any more bytes actually, because it's just replacing constants with defines. So since the screen is still blue, we know it's working, because every time I do a clear screen, it's clearing it to blue and then typing everything over it. So everything still works. Kernel, the calculator, everything else. So if we type a bunch of crap and clear screen manually, CLS, yeah, it's blue. Okay, so we're good. Okay, I'm going to change the make output real quick, because I was, I look up make things when I get annoyed with it. If we want to hide output, I think there's a command line flag you can pass to hide everything, but I want to show some things. But the hide output, I think you can just put an @ sign in front of things. So I'm going to do that. So normally make copies whatever these lines are, and then it types the output. I'm just going to hide that. This thing, I think I only have to hide the first one because the backslash at the end means it continues on. So these 4 lines are going to be executed as one in one sub-process. So I should only have to put it here, I think, because if I put it there, yeah, it's not a different color. Yeah. So it knows. That's good. The highlighting knows. I can keep clean and run, but for these things, we can reduce the make output just by putting an @ sign in front. And see, that's a lot better already. I don't really need to know the DD output though, so we can change that as well. But this is a lot easier to read. See, we know it assembled, and we can see the sizes more easily here. So that's good. Yeah, let me change the DD status. So wherever we have DD, it's probably printing stuff out. The way you can do that, DD has a status, and I don't know what you call this, option argument, whatever you call it. But it is a status thing. You can do, I think, xfer for only the transfer status, bytes actually moved, but you can also do none, and that should hide the output on DD. So where else do we have? Down here. I didn't mean to type that. Okay, whatever. Status equals none. And that should hide these like 280 plus 0 records in and out. That should hide all of those messages. So there we go. So we have the assembler passes and then the kernel passes. That's all I want to look at. If we make an error, the errors would still show up here, like from the Clang compiling things or FASM assembling things. But other than that, if there's no errors, I just want to know how big things are. So that's a lot easier to read. That's a lot less to take in. So that's pretty good. And I can check what sizes things are, because the file table is not huge right now. This is still D, so that's good. 13 and 6. So that's all fine. Okay. Okay, the only other thing, I think I want to do something else to the makefile, and that's making a similar a thing like we did here to tell the size of the assembled files. So let's add one of those. We'll add that line here. So I can run this again for this because it'll be a separate shell or subshell process than this thing down here. So I can probably do the same line. Actually, and it'll be okay, except this will be bin directory add a.bin. That would be the size, and then I'll probably want to, I don't want to expand it, because in the assembler we can actually extend things to the next sector boundary, but we'll just get the size of what it is, and we'll echo that out. So echo size should be okay. Divided by 512 sectors. We don't need the new size, so I think that'll be all right. And I don't need to say we're going to echo it, I just need to echo it, so we'll hide that output. Oh, we're already doing it with that @ sign. Okay, cool. So that should give the size of the assembled ones. Okay. I do not need to see this. I don't want to see that, because I already know what the size is now by doing this. So I'm going to hide that. FASM doesn't have a flag to hide the output, so I'm just going to do it the Linux or Unix way and just ensure standard out goes to null, or I'm going to explicitly put dev null. But let's see, there we go. So now we just get the assembled files and then the C files. So get to actually making the graphics stuff, man. Quit just talking and not doing anything. Okay, I'll do that. We'll do this to do here. Let's clear the screen first. We have our nice and handy dark gray or light gray. I'll try the light gray. We'll see how that is. If it's too blinding, then I'll go with the dark gray, but hopefully the light gray is not blinding because I made it below all Fs. So let's just ensure that that works right now. Actually, I need a way to go back. I need to go back to get input or do continue. Yeah, because that'll go back. Continue. All right. Did I call that input character? What did I call it? I forget. Yeah, input character. Okay. I don't really think you need to explicitly get the return value. You can just put get key, but that'll be like a warning. Even though I don't have warnings turned on in my compiler flags yet, which I probably should, but I'll just explicitly get a key here, and then I'll go back. So we'll do that. And then continue should go back to the top, and it should, I don't know if that clears everything, actually. Well, we'll find out. If it looks real jank, that means it didn't clear everything. Let's see, if we do graphics that's not too blinding. That's a little darker than white because this border is white, so you can see the contrast there. So we press any key. It goes back to the prompt, and then it prints it in the normal blue and white colors. Yeah, we'll clear the screen and move the cursor back, I guess. That would be good. That would look a little less jank. We'll clear it back to blue, and we'll set the cursor back. Because we're clearing the screen, we'll set them equal to 0. Yeah, it's a lot easier to read that output now, that's nice. I just want to know if the size changes on the files, because then I have to change it in the boot sector or the file table. But there we go, we clear the screen back after getting a key. We can still do things, so we're good. Okay. Cool, so now we want to draw stuff on that screen. So let's actually get to what this video should be about and go into here. The thing we're going to use, I'm assuming we're drawn in sort of a 2D plane, 2D space. I haven't done a lot of this stuff since like high school, which was, God, 8 to 10 years ago is when I took like trig and everything. So I'm not really going to be doing trig. I'm going to be doing real basic examples, but I probably also won't be able to explain them, at least for like drawing a circle and things, because I kind of just copied stuff out of books. So, oh well. But what I do remember is that there are things called points, or a lot of times when people do graphics, they use points as sort of a thing to draw with, something to connect lines with. Just expressing where you are within, you know, our coordinate system. Let's say we're using a coordinate system, X and Y. So I'm going to do that. I can do a struct point, or I'm gonna do a type def, so I don't have to type struct every time. We'll do a type def struct, we'll call it point with the big P so that I know it's a struct. I think that's a standard some people do. We'll make an X and Y. I'm gonna assume this is for our screen. Right now I'm doing with 1080p, so 1920 or 0 to 1919 effectively for the X values, and then 0 to 1079 for the Y values to get 1920 by 1080 or 1080p. So I'm going to have an X and Y point between, you know, those starting and ending values. That's going to be our point here. I don't expect it to be negative. I'm not sure if it would help to do an integer or not. 2000 or 1920 or whatever is well below the limit of a 32-bit number. So I'm just probably going to do 16-bit. But we'll have X and Y, I would think. I forget if this is the right way to do a struct. Okay. I didn't remember if you had to use semicolons or commas or what, you know. Because if I do a comma, it'll give me an error, right? Yeah, okay. Because the declaration list wouldn't be empty. I could do this and save a line. That would probably work, right? Yeah, that'd be equivalent. Okay. I know some people don't like when you do that, but I think here it makes perfect sense, so it doesn't really matter. It's either that, or if I have a function, I would have to do like uint16x, uint16y, which is fine. That works the same. Or if I do this, I can just say points, I don't know, p1 or something. So it's a little shorter, and if you know what a point is, I think it makes more sense. So that's probably what I'm going to be doing here. The first primitive I'm going to do, though, to start off with is probably the simplest one, which is just drawing a pixel. I think primitive is the right word for this, right? Graphics primitives. I'm probably going to do this similar to what I've done before. I can clear screen. We'll just have the frame buffer thing here. So we'll have a frame buffer, and we'll just draw at that specific point instead of going through a loop. So to get to that specific point, we can either add to the frame buffer itself. So we need to get the Y value for what row we're going to draw at. Which if we're passing in, it'd be P1. I'm not passing in by reference. I'm copying. That'll take up more data, but that's fine. Okay, P1.Y. And to get to the right row, we need to consider however many pixels are going to be in our row. This is going to be basically pixel granularity for these XY points. So we'll multiply by 1920. Then we'll do that. Well, we need to add the X value. Sorry, let me do that. And then we'll add the X value. So if we're on row 0, then we'll just draw however many pixels were into that row by the X value that's being passed in. If we're on row like 2, it'll multiply 2 by 1920 first to get down into that row in the screen, and then we'll go across however many X pixels we need to go to. And that's where we're going to draw our color. It's a 32-bit pointer, so we can draw a 32-bit value by dereferencing, making that equal to the color. And I'm not passing in a color. Let's pass in a color. There we go. And we'll set that equal. So we'll see if this works first. Let's put that in the kernel here. We'll test these things. So I'll draw a pixel test. We need to make a point first. I'll probably do it here. Normally I put everything at the top though, but I guess I'll do it here so it's next to it so it looks fine. That'll be fine. This will be points, P1 or P0 or whatever. Maybe I'll call it 0. I'll 0 offset, right? That'll make it a little more confusing. Because it's C, a 0 offset would mean we're at that point. So I'll change that to P0. I think I can just do this, right? Like .x equals and .y equals. I think I can do that within here. Let's put it, I guess like in the middle of the screen. So an easy way to do that is just going to be dividing by 2. That'll put it like approximately in the middle of the screen. It might be a little off because, well, this is going to be an integer value. If it was a floating point value, these are integers, so I think it'll cast them to an int if they were floating point or double or whatever. I don't remember if C casts them like to the floor or not. I don't remember how it rounds it, but oh well. 1080 divided by 2, or we could hard code, what, 960 and 540, but I'm not doing that. Oh, this needs to be curly brace. I think you can instantiate like that, but we'll see. Asset P0, what color do we want it to be? Let's try red. We'll try a red pixel in the middle of the screen to get some contrast. And it doesn't work. Defaults to int. Oh, and that is because I didn't say what type it was. I just said its color. Unless I want to do... that or something. I don't think that's how you do it. I'll just specify. That's fine. It's going to be a uint32. Type specifier missing. Nice. Defaults to int. Use of undeclared. That is because I called it P0 and didn't change it. You got to make mistakes. If I don't make a bunch of mistakes, how do you know I'm not human and not making it up on the spot? Type specifier missing. Oh, okay. It doesn't return anything. Wow. I mess everything up. This is how you code C, guys. You just don't do anything right. And, you know, you try to record something after you've been not feeling well, and it just goes to a crapshoot. That's okay. Let's give this a little comment too. Draw a single pixel to the screen. Is it going to work? Oh, now it works. If you fix all your problems, sometimes you just might find you get what you need. And I don't see anything. That doesn't mean there's nothing there. It means my eyes could be bad. I think there is something right there. I think that's a red pixel right there. I'll have to zoom in on the recording. Or I can just draw a box so it's easier to see, which would probably help a lot more, wouldn't it? So let's do that. Let's do that. Go back where it was. Draw a pixel. All right, let's draw a box. Instead, let's do like... Do I have standard like iterators up here or whatever? I have an index. I'll just make like I. People like I, right? Let's do I, 0. I don't know, 50. Well, these could be 8-bit if I do that. I plus. Let's do... This would be a line of pixels. Let's make a box. J less than 50, J plus plus. Let's do this. We'll draw a pixel at that position, so I'll do this. It'd look a little less jank if I surround it with brackets again, even though it's 2 more lines. Oh well. So what am I doing here other than messing up indentation? I'm going to set we'll do x equal to j. We'll do y equal to the I. So for a row of 50, for every x, 0 to 50 in that row, I'm going to draw a red pixel. Right now this will be 0 to 50, so it'll be the top left corner. I kind of want it to be in the middle so it's a little easier to see. And I might make it 100, just so it's bigger. So let's do that. Let's start off. 1920 divided by 2 is about like 960, right? And I also don't need this because I'm setting it up. Let's do, it'll be offset a little bit to the right. That's okay. 1080, half of that is 540. It'll be offset a little bit to the bottom right. That's all right. I'm not centering it. So let's see what that does. We'll offset it a little bit from the middle of the screen. Hopefully draw a red square. Which is a place in Russia. There we go. There's your big old red square. So that just proves that it works. We're drawing 50 pixels across. Where's my cursor? There's my cursor, but when I type anything, it goes away. 50, well, for 0 to 50 rows, for each row, I'm drawing 50 pixels across. So that's what this, or 100, sorry. For 0 to 100 rows, I'm drawing 100 pixels across. So draw pixel works. So that's cool. I guess the next easiest thing we could do is draw a line. Draw a line to the screen. And this time, hopefully I typed this right. We'll do draw line given probably 2 points. Yeah, so we want a starting point and an ending point. So we can do P0 to P1, or start and end. Maybe that would make more sense. It's a little bit easier to read, start and end. And we'll pass a color. Because what color do we want the line to be? So what I ended up doing was searching line algorithms the other day, right? Line drawing algorithms. This is, I guess, an easy one. You can, oh, this is the simplest one. This is really simple. If we wanted it to be a little more performant, we could do Bresenham's. We might try to do this first, though. But it could be negative. You could have a negative slope. Quite sparse. Ah, so this doesn't work really well. Yeah, let's do Bresenham's. So you can go through and read this on your own. I'm not going to explain it because I would not explain it right and it would be bad and wrong. And I have not done math for a long time, so I do want to learn it better. Like, I understand this is delta. This is the change in distance or whatever, right? Delta y. And they put 1/2 some things in there. Basically, we're getting like a decision parameter or an error, and we want to choose depending on the slope of the line that we're going to draw. If it's greater over an x distance or over a y distance, the line's going to be like steep. If it's y, it's going to be like that. If it's an x distance, it'll be like, you know, not as steep. It'll be a different slope. And we want to see where a pixel that we're going to draw, is it going to be like above the line, below the line, on the line? Whatever is closer, the x or the y distance that we're going to, whichever one's closer to the line or on the line, we want to draw that. We don't want to draw like way off into space. That's kind of what these algorithms are for. Bresenham has a sort of really good integer-based example that he uses, so we don't have to deal with floating point. This is a simple one for it, but you want to handle the case where you put like the start of the line is going to be like to the right of the end of the line. Like if you're drawing it backwards, then you're going to have a negative slope, and you kind of want to account for that, I guess. So they go through and account for all that. The code isn't really that bad, but I ended up doing, I think I ended up going with this before. So it's pretty short. Instead of going through and doing line low and line high, which are these two, we'll duplicate a bit of code 4 times. I'm just going to kind of probably do this, sort of copy and paste this to work with my example. So I'm going to do that right quick. All right, let's draw a line here, adapting for my variable names. This can be sort of, you know, what the Wikipedia thing said. So I'm going to make these ints. What am I making ints? dx and dy. I'm going to make integers and not unsigned integers because our slopes could be negative that we pass in. Or we could add code to switch the points if dx or dy are negative. Or we can just not do that. So we'll have this work with whatever we pass in. But we need a change in x and a change in y to get the slope that we want to draw. So the rise or the run. But how do we get those? We can get sort of the absolute value of the changes in x and the changes in y. So the changes in x will be probably the end minus the start. So end.x minus start.x. And then if that is negative, we want to negate it probably. So if dx is less than 0, dx is negative dx. To get the positive absolute value in all situations. I did see on Wikipedia and on some other articles that they were using abs, absolute value. I don't have a library with that built in. So if we want to use this, that's going to error. I could make like a macro or something or another function to call that does that. So I might do that. Yes, okay, so let's make an absolute value function just to make it read a little better, because this goes along with what I've seen online before. I'm going to do a nice little define macro, which is always nice and can never go wrong. Definitely doesn't make things harder to read. A book I found used A, Computer Graphics and Principles in C, which is like from the 90s, 2nd edition. It had like a round function that used an A, so I can use an A here. This could be whatever. This can be X, this can be Y. It's just some symbol to use when you're defining whatever this function is going to be. So it used A, I'm going to use A for lack of better symbols here. But we'll say if A is less than 0, I'm going to make a ternary here. Return A, otherwise return negative A. So that's simple enough. We'll probably want to wrap that in brackets though. So that should work. That'll replace a with whatever we're passing it to, or passing to it. So index minus startx, this whole sort of expression here would be passed in as a. So I don't think this will work, because this would say index minus startx less than 0. So I think it would be index minus startx less than 0. And we want this whole thing. So this is going to look a little jank, but I think I'm going to have to put double parentheses. Or maybe I can put triple parentheses up here for a. Maybe. I don't know. We'll see. I think this will get the absolute value though. Then we don't have to do that. So, okay, let's have a dy as well, the change in y. For whatever reason, they wanted it to work in like a more concise way. The nice folks that submit Wikipedia articles did a negative absolute value for y. So I'm going to go negative dy to ensure that that's always going to be a negative step on the slope for some reason. Oh well. I'm going to have a couple sign variables. These can probably just be 8-bit. A couple sign variables. I've seen it used as like xi and yi before, and a couple things. Or sx and yx. S might make more sense. I know these aren't great names, they're like 2 letters. I could also type out like delta x, if that makes more sense. I don't know. I don't know what would be easier to read. That might make more sense actually. This needs to be negative there. Delta y. We'll do that. That might be a little bit easier to read. We'll call this sine x and sine y. So sine x is going to be overall, what direction are we moving? Are we moving positive or negative in the x and y direction? So if we have a line that like goes up to the right, sine of x would be positive and sine of y would be positive. If we have a line that's just going like horizontal left to right, it's probably going to be positive. If we have a line that's horizontal right to left, start and then end, it's probably going to be negative. So this is saying, you know, what direction are we moving for the x and y direction? So positive or negative for either one. So if the starting x is less than the ending x, which means we're going left to right pretty much. The end is, you know, more than the start. We're going to the right on our screen from, you know, 0 to the end. Then it's going to be positive. So if it's that, I'm going to say it's 1. Otherwise, we're moving right to left somehow. It's going to be negative. So our sign is going to be 1 or negative 1. We'll do the same thing for the y direction. Are we moving up or down effectively? If our starting y is above the ending y will be more because we're going down from an initial origin in the top left of 0, 0. It's kind of what we're basing everything off of. So if the y is going down, it'll be 1. Otherwise, it can be negative 1. We're moving sort of end to start or whatever. We're going up. If we're going down the screen, it's positive. If we're going up the screen, the y direction would be decreasing, so it'll be negative. So then this is kind of based off Bressingham's algorithm. Let me put the source here actually. Taken or adapted, I can put adapted. Adapted from Wikipedia page on Bressingham's line algorithm. Or actually, these are lowercase. So if you search that, Wikipedia on that, you should find the page. Or I'll probably link it in the video description as well. That's where this is coming from. But okay, Bressingham used like an error or sort of decision parameter to decide, do we want to move in the x direction or the y direction whenever we're deciding the next pixel to draw as part of our line. So I'm going to call it error. It's really, I think 16 bits will hold it. It'll be error. We're going to start it out as dx plus dy, or well, delta x plus delta y. So we're going to add them both to get an initial error parameter. And whenever this error parameter variable passes a certain threshold, we're going to add to it or subtract from it. And we're going to use however much this equals to determine if we want to move in the x or y direction for the line. Which was a whole lot of words that didn't really say anything, but hopefully it makes more sense in the future. They had a thing called E2, which is just going to be 2 times the error. So maybe I'll call it error times 2 or something. That's fine. Okay, but for the actual little loop here for our algorithm, it's not very long. Not very long. We're going to draw an initial pixel at our x and y, which is where we're starting at. So start.x and start.y. Well, we're drawing using a point, right? So we have to pass that. So let's just pass in start and whatever color we passed in. So that'll draw the initial pixel to start the line off. Okay, how they did this, I don't really like it, but that's okay. Because they're putting in an if statement. Usually when you have a loop, you can use this as the terminating statement, but they're drawing and then doing this, so we don't miss off by one error or anything, but that's okay. I'm just going off what Wikipedia has. But okay, if our start, if we're at the end, our start x will equal the ending x, and the y's will be equal as well. If we've reached this point where the x's and y's are equal, then we're at the end of the line. We can stop drawing, we can break out of the loop and end. But if we're not at the end, then we're getting our error variable here, which is going to be error times 2. And if this value is greater than or equal to our change in y, which is always going to be a negative absolute value, but if we're greater than or equal to that, let's put this up on the screen a little bit more. Then we're going to add that y to the error. So we'll do error plus equal to delta y. And we're going to move in the x direction. So this is signifying that after our initial delta x delta y error, we're going to multiply by 2. For some reason, I forget. If that's greater than our change in y, then that's signifying we're moving in the x direction. So I'm going to add the change in y. But our next x that we're going to draw up here is going to be moved, you know, to the next pixel before the end of the line. So start x, we're going to add in our sign of x. So if we're moving left to right, it's positive. We're going to add a 1 to this x value. So the next pixel we draw is going to be 1 to the right. If the sign's negative, we're moving to the left to get to the end of the line. So this is going to be 1 pixel to the left. It'll add -1. Okay, that should be all right. Okay. On the other side of things, although this won't always happen, there are 2 separate if statements, but if our error times 2 value, in this case, is less than or equal, since we made our delta y always negative, we can do this. It shortens code a bit. If this is less than or equal, our change in x, which could be positive or negative, then we want to move in the y direction. So greater than or equal to delta y, we're going to move in the x direction, but add the delta y to the error. If it's less than or equal to the delta x, then we're going to add delta x to the error, and we're going to move in the y direction. Whether going down the screen for a positive y, positive sign, it'll add 1. If we're going up the screen, then it'll be a -1, and the y will decrease. And that's the whole loop here, which is pretty simple. That is what I got from here. That's what this is, effectively. I'll zoom in a bit. That's what this is, just adapted with my variable names. But that's what they chose. Some versions use integer incremental error to perform all octant line draws. So if you think of like the unit circle, there's 8 octants around the circle. We're kind of just deciding what direction to draw on one of those depending on the slope. This is just a concise version of that. And yes, this does not handle vertical and horizontal lines specifically either. We can add that to be fancy if we want. And yes, in this one, we can draw negative or positive slopes, so in whatever direction. There's also DDA, algorithm, and other things, but we're going to go with this for now. So this should draw any line, positive or negative slopes, going anywhere. We don't have to worry about it, so we can draw, you know, lines. So lines are fun. Let's see if that compiles first. Didn't mess anything up. We are at E sectors now, but I'm going to add a test to the kernel first before we do anything else. Let's add a draw line test, or a few. We'll do let's do horizontal line. We'll do vertical line. We'll do some sort of diagonal line. Let's go up and to the right. So up right, if that makes sense. And I'll go down and to the left, just Just to show we can do negative slopes on things. Up to the right, down, well, those would look the same though, so let's not do that. We can go down to the right as well, it's fine. Just to show we can do negative slopes. Okay. So horizontal, so we'll draw a line, we need to pass in 2 points. So I need to make 2 points. P1. So let's set the initial x to, we have a square in the middle of the screen. Let's move this square and we can like draw the lines in the middle or something. We can move the square up or to the up and to the left maybe. Let's just do like, we'll draw it at like 200. We'll see how that looks. We'll try to draw these like in the middle, I guess, maybe. Let's set this equal to half the screen width. We can offset it up a little bit, like the upper middle of the screen. So I'll subtract maybe like 100 or 200 or something. We'll do 200. And Y we'll do the middle of the screen, offset. Actually, this will be to the left. So I don't need to do that. I can just, well, I'll offset it to the left a little bit. We'll do 100 to the left. But the Y value will offset up 200. Okay, and then P1, if we want to do 100 pixels, we could end in the center. And then this would stay the same for a horizontal line. We're just going left to right, 100 pixels. Okay. P0, P1, let's draw just a black line. And then we'll try a vertical line. Vertical, let's put it to the right of the horizontal line so we can do 1920 by 2 plus 100. We can start this at, we'll say negative 100 to positive 100. So that'll be 200 pixels going straight down if I make the x's equal. So if the x's are equal and the y is changing, only the y, then it's just a straight vertical line. If the y is equal and the x's are changing, then it's going to be, you know, a horizontal line left to right. So hopefully that makes sense. We'll see what that looks like right now. Let's make this some other color like green. Just to get some difference. It may not work unless we change the sizes of things in the file table. So let's change that to E, which means I have to change the boot sector because I don't have a good thing to automatically pick that up. Not yet. In the future, I want to change this to where we just read the file table so I don't have to change these values all the time. But that's all right. We just changed those to be one more for the kernel and the boot sector. That's all that was doing. Let's see what that looks like. That doesn't look good now, does it? We do have a vertical line. I think I messed up somewhere because that does not look good. The vertical line looks okay. The horizontal does not. Not at all. And it crashed, so that's good. So what did I mess up? Probably everything. I usually mess everything up. Like typing in draw underscore. What did I change here? Start and end. I don't think this would have an effect, but I can try making these 16-bit. Just so they're all equal. I don't think that'll change it, though. But you never know. Oh, the absolute value is greater than 0. Sorry, I'm dumb. If you were yelling at your screen, you know, sorry about that. A needs to be positive. The absolute value, we're only negating if it's negative. If it's positive, we want to return the positive. Yeah, that probably like broke everything. Most definitely. Remember, absolute values are positive values. Yeah, there we go. It's kind of hard to see the green, but this is a black horizontal line. The green here is vertical. It's green. Maybe it's easy to see for you. For me, it's kind of hard to see. But then again, I have giant glasses because my eyesight's not 20/20 amazeballs. So I'm in kernel.c. Let's go to draw line. Remember, make absolute values positive. Let's try yellow would also be hard to see. We'll try purple. Purple might be a little bit, I'm gonna move it up actually to start where the other one's starting. It'll just be 100 pixels. I don't know if purple will be higher contrast and easier to see or not. Yeah, purple's a little easier to see, it's down here. So every time I go outside of the screen, it counts as a keystroke when I press Alt and stuff. So that's why it keeps going back. But here's horizontal, here's vertical. Diagonal lines. Let's look at diagonal lines. Let's move that down. Make it minus 100. If I want this to start at the same place, I can start this at minus 100. Okay, diagonal up and to the right. Might as well just put this here too. So up and to the right. I guess we'll put it to the right of these two. So we'll do positive 150 maybe. I'll start it at the middle of the screen. We'll go up, so we'll go to negative 100, and we'll put it at 250 or maybe 300. 150 pixels down right. Okay. We'll start this maybe at positive 200, so it this ends at 300. So let's put this at 350. Start it at 350. We'll go over to 450 or 500. This ends at negative 100, so maybe we can start at negative 100. We'll end at positive 100. That's fine. We'll see what that looks like. This will be... Make it dark gray. We'll make this one blue. Just a couple diagonal examples. We'll see what that looks like. Oh, so there we go. I mean, this shade is different from this black, even though it's hard to tell, but this goes up, this goes down. So we can draw diagonal lines. We can draw vertical, we can draw horizontal. Cool. These are only 1 pixel wide. I don't have anything for line thickness. I might make that part of like a paint application if I do that. But this is basic line drawing. Hopefully that makes some sense or at least looks interesting. Okay, so the simplest polygon, I guess if I want to think of a polygon, however many number of sides, the simplest 2D shape that is made of, let's say, connected lines is going to be 3 sides, right? 3 vertexes, 3 points in space for a triangle. You know, a square is made up of sort of 2 triangles if you can bisect it. Because if you just have 2 lines connecting, then it's 2 lines. But if you have 3 lines connecting, ooh, then we're getting fancy. Got some triangles there, some trig. But we're not going to go into trig at all. This is actually going to be very simple for my polygon drawings. Which also means it's probably not going to be very performant, but right now I don't have to worry about performance. I'm not doing 60 FPS video games or anything. I'm not worried about performance. But I am worried about eventually ending this video. So let's draw a triangle to the screen. I keep putting to the screen. We can just do draw a triangle. Draw a line. Draw a single pixel. Hopefully you see where I'm going with this. I'm trying to build up from smaller things. I'm building up from a pixel. This is calling draw pixel. Triangle is going to call draw line, I think. Void draw triangle. So this is going to be 3 points in space. So I'll do point P0 or, I mean, these are called like vertexes now, I guess, if they're polygons. I can make it V for vertex. Or maybe I call it vertex. I could do that, I guess. Whatever makes the most sense. I want this to be like, I'm not a good teacher, but I want it to be the most sense and the best, like, pedagogically, if that's a word. We'll have 3 points in space, vertex 0, 1, 2, or 1, 2, 3, and whatever color we want these to be. And the easiest way to draw 3 lines on the screen is drawing 3 lines on the screen, so that's what I'm gonna do. Draw lines between all 3 points. So I'm gonna draw a line from point 0 to point 1, or 1 to point 2, which would be vertex 0 to vertex 1. Color needs to be U132. U132T, okay. So draw a line from 0 to 1, draw a line from 1 to 2, and draw a line from 2 back to 0. And that should be all we have to do to draw like any arbitrary triangle. We're just drawing 3 lines on the screen and connecting the points. So this is also a way to see if we captured some off by 1 errors, because if we didn't, then there would be gaps between the points right at the end where they connect. So if they're all connected and it looks right, then we know we don't have any off by 1 drawing pixel errors. But this will just call draw line 3 times, and that calls draw pixel. So we're kind of trying to build up from smaller things. Okay. But that's actually, I mean, that should be all we need to do. So draw a line, let's have draw triangle tests. Maybe I could do a right angle one and a not, what is it when 2 sides are equal? Is that isosceles? So maybe we could do right angle. Right angle would be, the y value would be the same, right, for 2 of the sides. Well, the y value would be the same for one side. It'd just be a vertical line and then a horizontal line for another side, and then the rest would be a diagonal. So let's do 3 points now. P2. Let's do 3 points now. We'll add a P2 there. This is all in the middle. Let's put this in the bottom left, just to have, you know, separate space out from here. So 1920 over 2. Let's offset to the left. Yeah, you know, no, 600. This is 960, so this will only be like 300 off. That's fine. Let's start at the top of it. For right angle, I'm going to do 0.1, 0.2 below, 0.3 over here, and then it'll connect like that. This will start at so halfway in the screen maybe. We'll add a little bit. I'll add 100. Offset it down into the screen 100 from the middle. P1, I'm going to have the same X, but the Y will change. We'll do 200. We'll make it 100 pixels down for the height. And then P2 will be over to the right a ways. So we're going to go right from the first point, maybe 150 pixels. So minus 450. And then the Y value will be equal to the P1 Y value, so that it's a horizontal line. So vertical line, P0 to P1, the Y is changing, and then a horizontal line, P1 to P2, the X is changing. Yeah, okay. This will be draw a triangle. This will be P0, P1, P2. We'll make it, I don't think yellow would show up. We can try making it yellow though. I don't think it'll work that well, but we can try yellow. We'll see what happens. Hopefully that's a right angle. And I missed a thing. What line was that? 257. 267, that's close. There we go. It does take longer to compile when I'm recording at the same time. Oh, I don't see it. I don't see anything. Oh, there it is. Yeah, that's very faint. I'm not doing that. Can I have another color like burnt orange or something? Let me look up a color picker. And any one of these color codes, that sounds good. Give me a, yeah, sort of like burnt orange here. Let's do that. FF7233. Let's try that. So I will be hard coding this, forgive me. FF7233. Should be a sort of burnt orange. Sort of burnt orange. Just so it's easier to see on the screen. There's our triangle. See, right angle, the vertical line, P0 to P1, P1 to P2 is a horizontal, P2 back to P1 for the third line we're drawing is diagonal. That's a good right angle triangle. And that draws a triangle. Do I really need to draw the other two? I guess since I already said I would. I just want good examples, you know? But all we're doing is drawing 3 lines. I don't know, I'll do something different when we go to fill it in. I'll do a filled triangle later and we can do a different one. That's a right angle test and it works. Let's just do that for the sake of time. Because I don't want to be editing this video forever because I take too long to make it. Okay. So what do we want to do after a triangle? Let's add one more side to draw. So we'll make a rectangle. Draw a rectangle. So for a rectangle, you could pass 4 points, but since a rectangle is kind of defined to be, you know, parallel sides, right? We only really need to pass in 2 points to draw a rectangle. Let's put this in, yeah, let's make it first, doy. Let's draw a rectangle, and if all 4 sides are equal length, it's a square. So we could use this to draw squares as well, but let's do a rectangle. It'll be void again, draw, call it rect, or I can call it rectangle. Usually people do draw rect, and for this, I think some people do draw triangle's fine, but rect, I'll say it's rect. So points, we'll make 0 and 1. Color. The points you need can just be the top left point of the rectangle and the bottom right point. So going from the top left to the bottom right, we go across however many X pixels we need, and then we go down however many Y pixels we need. So really we can just say, you know, this X to this X, draw a horizontal line. And then at, you know, this X or this Y down to this Y, draw a vertical, then that is the bottom right, and then that X back to the left, the other X, draw a horizontal line, and then that X or that Y up to our initial point at the top left, that Y, we draw a vertical line. So horizontal, vertical, horizontal, vertical. So let's do the top first, top of rectangle. So we'll draw a line from vertex. 0 to 1 would be diagonal, so I don't want to do that. So I'll probably have to make the way I did this, I'll have to do some temporary variables here. So we'll do points, temp. Temp x will equal vertex 1, or the second point we're drawing to. I'm assuming that's the bottom right. I could call this top left, bottom right. Would that make more sense? That might make more sense. So I'm always drawing positive. This way I always draw positive values, usually. Well, you can draw negative slopes though with draw line, so never mind. But I'm always going in positive direction, X and Y, from the top left to the bottom right. That's kind of the point of doing this. So temp X, let's equal the bottom right dot X, and then temp Y will equal top left dot X. And then we can pass draw line, top left point, and temp. And it'll draw a horizontal line for the top of the rectangle, just going across the X direction. Let's draw right side. Right side will be drawing a line from our temporary point, which is, I guess, the top right now. Draw from temp to bottom right. Oh, we need to pass the color in as well before I forget that. Since the X values are equal, the Y value will be changing from top left to bottom right Y, so this will draw a vertical line down for the right side. Let's put some spaces there at the bottom. We can draw left, so I can show that negative slopes work with draw line. Draw from the bottom right to, well, let's redo temp. The temp Y will equal the bottom right Y. Yeah, we'll change the X value to the left X value, and the Y value will be the bottom Y value. And then we'll draw from the bottom right to temp, so that the Y values are the same, but the X value changes going to the left. That'll draw the bottom of the rectangle, and then we'll draw the left side. So I'm going clockwise here. You can go in whatever other order directions you want. There's probably a way to do it more performant and easier, more concise, but this is what I'm doing for, I guess, for learning. We'll draw from temp. which is at the bottom left right now. We'll draw that back up to the top left. Pass our color. So 4 lines to draw a rectangle, so there you go. So let's go down here, draw a rectangle test. You can put it next to the triangle, I guess. We'll do that. So P0, let's do... So where does this end? Minus 450, we can do minus 400. Or the top part of this is at plus 100, so let's do that. And then for the bottom right point, let's go across, I don't know, 300 pixels. Maybe it'll run into one of the lines or something, but we'll go across 300 pixels and we'll go down, I don't know, 100 pixels. It'll be like a skinny triangle or rectangle. We go down maybe 200 actually. So we'll do plus 300. And it was draw rect, P0, P1. We can make it the burnt orange color again. I want to get some fancy colors, but you can't, these are like single pixel lines, so they're not gonna stand out that much. But we can try for some other contrasty color, like a nice, whatever this is, teal, kind of teal color. 33CEFF, yeah, we'll try that. CEFF, I think that's what it was. Kind of teal, maybe. I keep forgetting. Type specifier missing. It needs to be a point. Yeah, why do I always forget these things? I know it's a point in my head, but when I type it, I don't realize I'm not typing the whole thing. That's usually what syntax highlighting is for, but you know. Oh well. Oh, guard local. Oh, it doesn't like it. It doesn't like me passing temp. Okay. So I have run into this before. This is, I mean, it's a good thing. It's telling you, hey, there's a potential that you're going to mess up the stack. However, for the purposes of these examples and everything, I know I'm not really going to mess up the stack. So this is kind of just annoying me. And I think it's because these are enabled by default on OpenBSD. I can add a flag to get rid of that. I think it's F no stack protector. I think that's what it was. Or no stack protection. It's something like that. I think that's what it is. Yeah, it's F no stack protector. So, I mean, normally you probably shouldn't disable that because you might have some stack overflow errors if you disable it. But for what I'm doing, I don't think that's going to happen. I don't need that error getting in my way. Oh, well, stuff's wrong here. Oh, we're at F sectors now. Yeah. These things do take up a lot of bytes. We're not in assembly anymore. So stuff takes up a fair bit more bytes. You know, if you want something cool and all in assembly and very well made, look up MinWet.os. But for me, yeah, we're just doing things, you know, not performance oriented at all, not space size constrained at all. All right, so that is not what I wanted at all. That's not good. That's like a giant trapezoid or something. So that's obviously not great. So something I did is wrong. Yeah, that should not be X. This should be Y. That's a red flag. That should be a Y, not an X. It's a Y value. Maybe that's why it told me that error. I don't know. It was just saying it very kindly behind the guise of a stack protection, guard local, instead of what really happened, which is me being an idiot. This is a rectangle, but it's not. It needs to be cut off like down here. Something still ain't right. Rect is lowercase. Yes, P0 to P1. I mean, I could set this initialized to the bottom right, and then just change this. That would be one less line. Oh, 1920. This needs to be 1080. 1080, it's the Y value. Wow. Yeah, that would make sense why it would go off the screen, because that's way farther than the bottom of the screen. And I don't have an infinite scrolling screen space. There we go. Look at that. get the top, get the right, get the left, so it does draw in the negative direction. Draw line works for that, and then back. So drawing those 4 lines. So that works. I might make that a little bit skinnier though. I want it to do source. Let's go 200. There, I'll draw a little skinnier rectangle. There we go. So it's a rectangle. Okay. What do I want to do after a rectangle? We could draw like a generic polygon, try to draw something. Okay, if I want to just draw a generic polygon, we can pass in however many points we want to do for that. So I'm probably just going to do an array of points. So I can pass a pointer to an array or just say it's going to be an array. So this will be like an n-sided polygon or however many sides we want to use. It'll just be more than 4 sides, I guess. Or at least more than 3 sides. We could probably draw a triangle with this function. I just wanted that to be separate to be explicit, but I think a triangle is technically a polygon just with 3 sides, right? So we could really do everything with this function. Let's do like a vertex array. So we can make an array. I guess this would be equivalent to passing a pointer, but I want to say we're passing an array of points. So I'll put the brackets there. You can't, if it's only 1 dimension, or I think the highest dimension in C, then you can have it be blank. For a 2-dimensional array, you can make the first thing blank and the second one you can fill with like, 5 or whatever. Like this would also be valid, I think, but if we're just doing 1 dimension, we can leave it blank, it's fine. But an array of X and Y values, an array of vertexes, or vertices is the word, right? Multiple. Or an array of vertices that we're going to draw our polygon from. How do we know how big it is? I'm going to also pass in, let's limit right now to 255. We'll have number of points or number of vertices. That's basically the array size. Is what I'm going to use that for. And we'll have a whatever color we want to draw it as. So how do I do this? I'm basically going to do a couple lines that are a couple statements that are just going to call draw line again. But I'm going to draw lines up to the last line, and then I'm going to draw the last line. You'll see why in 1 second. I'm going to use a for loop. Let's do I guess 0. Yeah, 0 because we have to 0 offset. 0-based indexing and for C arrays. We'll do up to the number of vertices. I'm going to index the array, so I'm going to do -1, because if we do vertex array offset or index num vertices, that's going to be invalid. That's not right. So we could get weird memory corruption from that. So we'll do this. And we only really need a one-liner. I'm just going to draw a line from our vertex array, whatever point we're on. We're starting at 0. We want to go to the next point. So we're going to do 1, 2, I plus 1, effectively. And pass the color in. But that will stop before the last line, so we need to draw that as well. So this will be basically num vertices. Well, it'll stop at -1, so we can do -1. And it'll go to the first point in the array. First point will be 0. So if we draw like a hexagon or an octagon or just random lines or whatever, we want to draw every line up until the last one. Since we can't do the last one to the first one within a one-line for loop, I'm just drawing the last one right after explicitly. So if we draw like a hexagon and go to the end, we want to draw the last, the last line there. That's all that's doing. So that's pretty simple. That'll draw a polygon. Should draw a polygon. Should draw a triangle if we just pass 3 vertices. Or rectangle if we pass 4. But we'll draw something. Maybe a hexagon for an example, or an octagon for a stop sign, or something. The octagon at the Ocho. So let's do draw polygon test. That'll be an array of points. Let's make an array. Points, array. I don't know, vertex, well, we'll do that. Yeah, vertex array. Vertex array, let's make this 6 points for now. So this is going to be annoying filling it all out, but that's okay. We'll do 0. I can put this next to the rectangle, so that's fine. So we'll start it. Where does this end? The x ends at -100. We'll just do the middle of the screen. I don't know if this will run into the lines or not. We'll find out. I'll change it if it does. We'll do the middle of the screen. And this will be 1080. Starts at +100. We can do that. 0, 1, 2, 3, 4, 5. It is going to be long. This be 1. Let's see. Let's draw like... I did 6 points. Let's draw a hexagon. Even though it's not some fancy thing, I'll draw a hexagon. So it's 6 sides. So I'm going to go like clockwise. So the top, whatever left thing. I'm starting here, and then I'll go across for the top. So the x will be, I don't know, 100, I guess. And the y will stay the same. Then I'm going to go like down. So x will be, let's do 150. And then the y will change. We'll do the y change as well, 150. And then I'll do a vertical line down. I'll do 200. Then I want to go down and to the left. Again by 50. And y will increase 250 maybe, because it'll be going down. And then we want to do a horizontal line to the left. No, we'll need more than this. Isn't a hexagon. A hexagon, I'm thinking of an octagon still because I'm stupid. All right. Yeah, top, and then we go to a point, and then we go back. Yeah. Jeez, okay. No, I want to go... Yeah, we need a horizontal line for the top. And then I want to go down to the right. 50, we'll do 200. And then down 150, sure. And then we want to go down back to the left. The x will be whatever the other one was, 100. No, y can be 200. So let me separate this out. Increment x, and x and y, then decrement back, but the y is greater. Okay, that's fine. Then we just want to go to the left again. 100 will go back to 0 for the middle. Then we want to go up to the other points, which is going to be, we'll decrease by 100, and we'll go up to 150. And then the 6th point will be the first point. So that'll be okay. So what we can do now is do draw polygon, pass in the vertex array, pass in the number of points, which is going to be 6, 0 through 5, 0, 1, 2, 3, 4, 5, yeah, 6. Count on your fingers, make sure. And the color, red again, that's fine. I'll do a red polygon. No member name Y, because it's a capital. Because it's a capital Y. Why did I do lowercase? I don't know. Because I wasn't looking. Because I wasn't looking. Still F sectors. That's good. So it's a little wonky looking, but that is a hexagon. Right? We drew this point, then this point, drew a line to here, line back to here, back to here, back to here, back to here. So it's a hexagon. So we got all our polygons out of the way. We could probably also call it with these points and a 3 for the number to draw a triangle, and then these points and a 4 to draw the rectangle. I just have those separate to make it easier to understand. Okay. So what can we do now that we've drawn all straight angle things? We can draw probably curved things. By that I mean an infinite number of points. By that I mean not really infinite, but more a circle. Yeah, circle. So this isn't a big function. It's pretty small, but I want to show where I got it from because I like to cite my sources because I wouldn't be able to explain it on my own. So I'm a dum-dum. Okay, computer graphics, principles and practice in C, second edition. That's what this is. Output primitives, circle. So this goes through and explains. I don't know if I can put links to PDFs that aren't in print, but may not be technically free to acquire. But I'm sure you can find this PDF on your own somewhere, right? Computer graphics, principles and practice in C, second edition. It was in the 90s, but it makes sense. So this goes and explains, you know, we're drawing basically 8 points in each octant of the circle. So once we find out 1 point, we can use symmetry to draw the other 7. And we just go and draw basically in one of the octants, or well, it's a quadrant, but if we sect it more, it's bisect it more, it's octants. But if we do quadrants and we just draw 4 symmetrical points, we could like start here, and then draw one arc for the quadrant, and then symmetry will handle drawing the other 3. Or if there's octants, we can draw one octant, and then symmetry can handle the other 7. So we're really just going to be drawing, you know, figuring out the x and y for an octant, deciding where to move in what direction to draw the next xy point of that curve on the octant, and then draw the rest through symmetry. So I didn't explain how that works, but that's what we're going to be doing. And yeah, circle x plus y minus r squared for a midpoint function. It's kind of like Bresenham with the line. We're just trying to determine if the point we want to draw is close enough on the inside or outside or on the line. And we end up with the midpoint. I'm using the midpoint algorithm is what I'm going to be doing. This ends up drawing stuff. So basically I'm doing this function here. This is p plus equal, it's hard to read, plus equal to times x plus 1, plus equal to times x minus y plus 1. So you start y at the radius. X is 0, so 0 to the radius. We're going in like whatever octant the up and right is. P is some point 1 minus the radius. First we plot 8 by taking, you know, the first 8 symmetrical points that we start at, and then we get the rest as we draw the curve. So while x is not at the radius yet, we're going to increment. Our p, or 1 minus the radius, is negative. Then we're going to add 2 times the x plus 1, otherwise it's positive or equal to 0. We're going to subtract the y for the next point, and add 2 times x minus y plus 1, and then draw those points, and keep going until your x is equal to or greater than the starting radius. That draws a circle, so that's what I'm going to be typing out. So let's do this down here. Draw a circle. I'm also going to draw an ellipse after this, but you can think of a circle as an ellipse where both radiuses, radii, I guess, where both radii, horizontal and vertical, of an ellipse. If they're both equal, you have a circle. Same thing with a square compared to a rectangle. If all sides are equal, a square is a rectangle, or a rectangle is a square. If all the sides are equal. An ellipse is a circle if both radii are equal. I think that's right. I could be talking out my butt though, like I'm wanting to do. Void draw circle. So I'm going to pass in a point. Again, it's going to be the center of the circle we want to draw, so I'll call it center. And then however big the circle is going to be the radius. I probably want a positive radius, right? That would make sense. I don't think we could have a negative radius. That'd be kind of weird. So let's do uint16 radius and whatever color we want it to be, which will be uint32. Just put this here so we get it up on the screen some more. Okay, so let's have an x and a y. X is going to start at 0. This needs to be a t. Y is going to start at the radius, so we're going to move from 0 to the radius to draw, you know, our octant that we're going to do. And we're going to have a p value. I forget what that stands for, but they used a p. P is going to be 1 minus the radius. That wouldn't be an inverse, right? It'd be just some other complement or something. I don't know what you call it, but I'm going to draw the initial how they did it, you could probably make it all in one loop without drawing points multiple times, but that's just how the book had it, so that's how I'm doing it. So draw initial 8 octant points. So center.x plus whatever x we're currently on. And then center.y plus the y. And then the color. 2, 3, 4, 5, 6, 7, 8. We'll do center minus x and plus y. We'll do plus x and minus y. And then minus x and minus y. And then we'll switch these around. We'll do plus y and plus x. Oh, can't type. Minus y and plus x. Plus y minus x. And minus y and minus x. So this gets all 8 octants of the circle that we're going to draw. Since we have the first point, we can do symmetry from all of those. This is the first point. These other 7 octants are, you know, from symmetry. Okay, and then we want to loop and draw the rest of the points. So while x is less than y, while we have not reached the radius yet with our temporary x value here, we want to keep drawing points. So I'm going to go increment x for the next point, and now we need to see if we want to move in the y direction or not. So if p is less than 0, I can add 2 times x plus 1. Otherwise, we can subtract decrement y and add 2 times x minus y plus 1. And then we can draw the other points. So it is duplicated code here for this. So I think maybe you could do a do while and then just have this once up here instead of having it twice. That might be something to do if you want to optimize a little bit for lines of code or whatever else. But this is all we need to do. Draw next set of 8 octant points. So we're just drawing the 1 octant on the circle and then going up, I guess. Because we're decrementing y in this case. So decrement would go up, so we're drawing like this octant going up. And then every point in that little curve there, we're drawing the other 7 symmetrical octants. Okay. If any of that made sense, it didn't because I can't explain, but that is all right. Let's draw a circle. Let's draw a circle. Draw a circle test. Let's give it a center. Let's just do... Where do we want the center to be and the radius and everything? We can do the bottom right, I guess, or we can do next to the hexagon. 1920 by 2 plus 200, so we can do plus 300. Actually, we want the radius, that'll go to the left a bit, so let's do 350, we'll make the radius 50. The top y up here is plus 100, the middle one's plus 2. We can do plus 2. Offset it 200 down. Then the radius I can make like 50, that'll be fine. We'll pass it P0, 50 for the radius. The color, I'll make it blue. And we'll see if that does anything and looks okay. It doesn't, obviously. Too many arguments, expected 2. Oh, for draw pixel? Yeah, that's why. Yeah, draw pixel only takes a single point, and I'm offsetting. Okay. That's annoying. I need a temporary point. Sorry about this. But then I'll have to do this. Oh, that's annoying, dude. So I could either make a lot more code or put in an X and Y up here. I don't know. I like working with a point though, it makes sense. So this would just be taking in an X and Y value for draw pixel. Start it off as center. It's a lot of extra code. But that's all right. Actually, we'll have to do this. This is not great. This is not great. But it does make that look a little better. We have to do that, basically. Or I could just make draw pixel taking an x and y value instead. I can do that. We'll do that. Start.x, start.y. Let's just mess everything else up. We'll do that. This will be y plus x. That we call draw pixel. We call it down here as well. That's the only other place. Okay. I'll copy that line and put it back. Okay, and then that'll work. This all should work. But instead of p0, we have to do .x and .y. But everything else should be okay, because we're not calling draw pixel directly other than there. So that might work. No, it didn't really like that. Too few, expected 4. Draw pixel has X, Y, and color. Oh. Don't need that comma there. There we go. There we go. The kernel is 16 sectors now, however. That's okay. Do 1, 0 there. And this will be F. This will be 1, 0. This will be 1, 0. Okay. So we'll have to increase the kernel a bit during this. That is all right. Hopefully everything else works. I just changed draw pixel, but it wasn't that big of a change, which is good. And everything else does work. Okay. So here's that 50 radius circle from our center point we gave. It draws it. It's pretty good. Cool beans. Okay. So what can we draw after a circle? We can draw a football, or well, an elongated circle, by which I mean an ellipse. That'll be the last primitive, the last 2D line drawing sort of thing, primitive I'm going to do. So I think that's all we really need. Well, other than like curves, like Bezier curves or something, I'm not doing that in this episode. So sorry if you wanted something really cool, I'm not doing that because that takes a bit more code. This is also going to be taken from this book. I'll just show the ellipse. That's the circle algorithm. Make that a little bit bigger. So we get a thing for an ellipse. An ellipse, depending on each radius, or well, the regions they're saying. It's kind of like the quadrants and the circle and everything. They're defining a couple regions. This is region 1. This is region 2. So region 1 would be sort of similar to the first octant that we're drawing in the circle algorithm, where we just get a point, draw the other 7 points, and then decrement the y to draw this. That's kind of what we were doing for the circle. That's what this is doing. But then we're also doing another one for region 2. So going from that point, and then I guess incrementing y down to here. So that's sort of what we're going to do to draw the ellipse. And that should work. This is what they did. Oh, battery's out on the camera. Sorry about that. I'll be back in a minute. Anyway, here, so the same book, Computer Graphics, Principles and Practice in C, 2nd edition. This is for the midpoint algorithm for an ellipse and not the circle. We have a rounding function here to round to an integer here, rounding up from 0.5. You give it a center point, and you give it an x radius, or a width of the ellipse, and a y radius for the vertical So they have rx squared and ry squared, and then also rx squared times 2 and ry squared times 2. They have another p-value. Our starting x is 0, our starting y is the y radius. Now px is 0, py, 2rx squared times y. So we have our two regions that I showed briefly. So to draw the first region of our quadrant or octant that we're drawing, well, first they draw the first set of points, but the first region, we're rounding ry squared minus rx squared times ry plus 0.25 times rx squared. While px is less than py, add x, add 2ry squared to px. If p is less than 0, add 2ry squared plus px to p. Else, decrement y, decrement 2rx squared from py, and add ry squared plus px minus py to p. It's kind of like the circle algorithm, but we're doing two parts. We're basically kind of drawing two circles. One for the y radius, one for the x radius, sort of. That's kind of why there's two regions here. And this, you know, I can't explain why these exact values were chosen because I haven't taken math in a long time. But this is kind of similar to drawing this just for the second region. Decrementing y and using rx squared instead of, well, we're decrementing y there. It kind of switches. X plus plus, y minus minus, y minus minus, x plus plus. And then switching the rx and ry squareds and stuff. Okay, and we're drawing the points, which this we're doing quadrants and not octants. 4 points. Plus x plus y minus x plus y plus x minus y minus x minus y from the center. Okay, but we're going to be doing this, a version of this. It'll be a little more verbose than the circle one, but that's okay. Okay, so let's give it a center point. We'll give it an x and y radius. So radius x, radius y, and the color we want to draw the ellipse as. I guess when I was testing this before, I had issues with 16-bit values because we're doing multiplying of things. So these I'm making 32-bit. I'm not sure if they all have to be 32-bit, but it was easy making them all 32-bit. So this does take up a bit more space, but that's okay. This was the first line, rx times rx, except this will be radius x. Radius x times radius x. This will be y squared. Well, at least for the initial parms. But rx squared and ry squared, then 2rx squared equals 2 times rx squared, and the same for ry. 2ry squared is 2 times ry squared. And then we have a p-value. We have an x value, which is going to be 0. We have a y value, which is initialized to radius y. We have a px value, initialized to 0. And a py value, initialized to 2rx squared times y. Okay. So we're gonna, like the circle, draw our initial points first. So I'll draw initial for, these will be quadrant points. These will be calls to draw pixel, which is center x plus x, center y plus center dot, center y plus y. 2, 3, center x, minus x and plus y. If I can do the minus, plus x minus y, and minus x and minus y. Yeah. So we're just doing quadrants, not octants for this. You could probably change it to do octants. I'm not sure why the book did quadrants, maybe to take up less space or something. But I don't know. But it did say we're drawing two regions here, region 1 and 2. They did use a rounding function as well, so let me put that at the top. Absolute values, we'll define round a as, I think it was a plus 0.5, and that was int. So we're casting to an int. It's all within parentheses. int a plus 0.5 ry squared minus rx squared times ry, which is radius y, plus 0.25 times rx squared. So after we set the initial p-value, while px is less than py, we'll increment x. We'll add 2 ry squared to px, and then if p is negative from rounding, then we'll add ry squared plus px. Else we'll decrement y, we'll subtract 2 rx squared from py, and we'll add ry squared plus px minus py to our p. So we're having like two p-values. Well, we have an overall p-value, you know, which determines what direction we move in to draw the next pixel at and stuff. We have an overall p-value, and then we have additional p-values for the x, or width, and the y, or height, for the ellipse. For the circle, we only had the one p-value, but since we have two different radiuses, radii, however you say it, two different radii to worry about, we have initial px and py values for those. Okay, if that makes sense. It doesn't to me because I don't fully get it, but I know it works, so it works. And then we draw the quadrant points again. So I'm going to end up drawing these 3 times, you know, less efficient, more lines of code, unfortunately, but oh well. Okay, so that's the first region. Then we want to draw the points for region 2. So for that, we get another p-value. These are separate while loops, sorry. Yeah, region 2, those are all the region 1 points. After that, we're going to reinitialize and do all these for region 2. Okay. So for region 2, for the initial p, we're going to round off y, ry squared, multiplied by x plus 0.5, and our x was initialized to 0. Well, it's whatever x is after being incremented throughout region 1, whatever that ends up as. We're going to add 0.5 to that twice, so x plus 0.5 squared, or whatever. X plus 0.5 times x plus 0.5. We're going to add rx squared times y minus 1 squared. So y minus 1 times y minus 1 minus rx squared times ry squared, which is a mouthful. And then we check, well, y is greater than 0. We want to decrement it. We want to subtract 2 rx squared from py. If p is positive, wow, I can't type. There we go. If p is positive, I'm going to add rx squared plus py to p, going in the y direction. Else it's not positive. It's 0 or negative. We're going to increment x. We're going to add in 2 ry squared to px. We're going to add rx squared minus py plus px. So rx squared minus py plus px, we're going to add to p. I think that's all. Yeah, and then we're going to draw the points for region 2. That is all we have to do, cap off that while loop. So region 1 and region 2, sort of drawing two sort of circles. I think if we pass in equal radiuses, equal radii for radius x and y, then this would draw a circle. It's just a bit more work, because we're working with two different radii. Anyway, that draws an ellipse. We can test that out by making a test. So we need a center point. I'm going to put this under where the triangle was, our right angle. Here, diagonal, no, draw a triangle. So this second point, this is minus 600 and plus 200. So I'll do minus 600 and I'll do plus like 300. I lost my place. There we go. Let's do plus 300. I want this to basically be underneath the triangle example. We'll do plus 4 because we'll have a radius that we're working with. So that'll be close to the bottom of the screen. Let's do 350. And we want to pass in the center. The center, the X and Y radius, and the color. Okay. So this will be the center point. The X radius, let's make 100. The Y radius, I'll make 50. And I don't, if green will show up, all right, we'll do green. If not, we can do something else. I can do green. I'll make it a little darker. So I'll do minus 2. So this will be FF minus 2, so that'll be DD. So really I could just pass that in instead. But that's how you offset from a green. This will make it a shade or a couple shades darker. So that's one way to do that. Let's see if the ellipse shows up. Oh, type specifier missing. It would help if I didn't make mistakes, but you know, I gotta forget. Always have to forget. It's just a warning though, it knew what I meant. It knows what I mean. I keep saying, why would I care about what the types are? These will be yeah, 16-bit unsigned integers. We want to be positive, and now the kernel is bloated beyond compare. It is now at 18 sectors, so I need to handle that. So 12 minus 1 is going to be 11, 12, 12, okay. And we're good, hopefully. What does that ellipse look like? Probably looks terrible. It's, oh, well, I didn't do something right. The edges are cut off. It's not good. They're just vertical lines. Well, that's kind of like a football. Not quite an ellipse, though. I got to work on that. Okay, so I must have typed something in wrong. Probably did. Let's work on that. Kind of like a football. This needs to be minus py. I had a plus py, so if p is greater than 0 in region 2, you want to add rx squared minus py, not add them together. And this is still plus. Okay. Yeah, that was probably not right. All it takes is one symbol. Not even a one line change, a one character change. Oh, there we go. That's an ellipse. Those are curved now. I'm going to make that green a little bit darker though, because it's still hard for me to see. So let's subtract 5. Yeah. Be FF minus 5. Well, we'll see what that looks like. There we go. It's a bit darker green. So it's an ellipse. See, the circle is equal all the way around. The ellipse has the Y radius and the X radius. So those are going to be all the sort of shapes for the primitives I'm going to draw. Lines, triangle, rectangle, some sort of polygon, circle, ellipse. That's all I'm going to do today for those. I will show how to fill in those shapes though, in case you want solid colors. Like I did for the rectangle in gfxtst. But for one sort of simple way that we want to fill in the colors, and we can use either, there's kind of two simple algorithms you could use. Flood fill or boundary fill is what I'm going to use, which is just taking a pixel, seeing what color that is. And then flood fill would be filling all pixels of a certain color with another color within some boundary color of our shape. Boundary fill is just not checking what it is, just filling in colors until you hit a boundary, I think. Something like that. I don't know. They're very similar. I'm going to be using boundary fill to fill in these shapes, and it's actually pretty small function here. Let's do fill a generic area with a color. This will be solid. No gradients or anything. We're going very simple for this one. Fill an area with a solid color. So this will be boundary fill. Boundary fill algorithm. I'm going to take in a point, which is somewhere within the area we want to fill. Let's call it a point. It'll be point P. We'll have a color. We'll have a fill color and a boundary color. A fill columns and a boundary columns. No, a fill color and a boundary color. So we need to check, given the point, we need to check that point and around that point to see what the color is. If there's, somewhere around the point that is not the boundary color, then we can make it the fill color. If somewhere around the point is the boundary color, then we've hit a boundary. We don't want to go beyond that point and spill out. We're not interested in doing that. This is going to be a recursive version because it's shorter, may use a lot of stack space. So if you have a huge area you want to fill, then you're going to have a larger stack than what I've given so far in this OS. But for any decently sized shape or area you want to fill, this should be okay. Hopefully. If not, then I can increase the stack size. I'm going to set up the frame buffer again. Just do that there. Actually, I can do the second one as well. This will be from the point we got in p.y, p.x. Okay, so if the color that we're currently at, so dereferencing the 32-bit value from the pointer, that'll be effectively the color on that screen pixel. So if the color is not the color that we're going for, you could get rid of this check. This is just an extra check, but we're putting it there anyway. If it's not the fill color that we want, and we're not at the boundary, so it's not equal to the boundary color, then we want to fill that in with the color. Which effectively we can just set that. We could do draw pixel instead of using frame buffer here, but I need to be able to check the color, so I might as well just put all this in here so it doesn't matter. So we'll do this. Frame buffer equals the fill color. So if the color is not the color we want it to be, and we haven't hit the boundary of the area we're filling in, then we want to keep filling it in. So we set that equal to the fill color that's passed in. And then we want to check pixels around that current one. People check for 4 or 8, depending on the shape you're doing. It could be better for large areas to check the 8 pixels around this. I'm going to check the 4 pixels around this area because I have sort of points, like if, the triangle ends the triangle ends at the end of 2 diagonal edges. And if you check for 8 pixels around, then the diagonal pixels that are outside of that point, like here and here, those will count, and we'll end up filling everything, and we don't want that. We want to stop, if we're filling a triangle, we want to only fill in inside of that triangle. So that's why we're only checking 4 to prevent that issue from spilling out. So to do this recursively, we can call in boundary fill. It actually is probably easier to take in an X and a Y instead of a point. So sorry, I gotta change this again. Let's take in an X and a Y value. You want 16ty, then another comma. We can just do this. Okay. Because then I can put in, this needs to be X. Then I can put in X plus 1, Y. Fill color, boundary color. Fill that in. Let's do X minus 1Y. X, Y plus 1. These Y's need to be capital. And X, Y minus 1. These will check the 4 cardinal directions around the current pixel. So to the right with the same Y, to the left with the same Y, above with this, or well, below with the same X and above with the same X, or plus and minus, below and above. And there you go. It's recursive. It's not in a loop, which might be better, but this uses stack space, but it's very short if we do it this way. So recursion is cool sometimes. So we're just filling in with a color, and then we're checking, you know, each additional call, checking if it's the fill or the boundary color. We stop when we hit the boundary. And yeah, that's a way to fill an area. So we can either fill in like an outline for a square or whatever, or we can draw like a solid color polygon without a different outline, however we want to do that. I'm going to do solid ones, like if, let's say like in JavaScript, I think there's draw rect and fill rect, like for the canvas. Draw rect is just a square, like an outline, and fill rect draws a solid color. It doesn't draw the outline. So that's what I'm going to do. I'm just going to draw the whole thing a solid color. If you want a different border, then you can just draw the outline on top of the filled in space, right? I'll start with fill triangle. Phil Collins triangle. Fill triangle. Let me call it fill triangle solid for solid color fill. In case I do want to go on to like gradients or other fancy things in the future, then I can do fill triangle gradient and it'll look a little bit different. We'll do fill shape solid during this. So fill triangle with a solid color, and this will not have a different colored outline. You can draw over it if you want a different colored like border outline for these. But fill triangle solid, we're going to do 3 points again. Point P0, P1, P2, which I need to put point for all these. And whatever color we want it to be. This will be a solid color. T. Okay. To be able to use our boundary fill to fill in the shapes, we need a point inside of the shape, not on the boundary. The easiest way, at least for a triangle, to get that would probably be getting the center of a triangle. I think that's called a centroid, which is a cool name. But to get the center or centroid of a triangle, the point we want to draw in, I'm going to have a temporary point maybe. Let's do that. Point temp. So to get the center, we can just add all the points together and then average by 3. So getting the average of all the points, that'll get the center of the triangle. That'll get the centroid. So P0, X, plus P1, plus P2. Divide those all by 3. I'll put in parentheses to make sure. Do that, and then we'll do the same for the Y values. And that will be the center of the triangle. And then we can pass that into boundary fill. And it'll fill in a triangle area, but we wouldn't, well, normally it would, but we don't have any boundaries drawn for the triangle yet, so let's do that first. So first draw triangle sides. So effectively these will be boundaries that we want to fill in with color. Now we want to draw the triangle first. So let's draw triangle using P0, P1, and P2. If we want to fill something in using boundary fill, we need a different color for the boundaries that we want to check against. So we want to fill it with the color that we pass to this function, but the boundaries have to be a different color. So it could be any color as long as it's different. One easy way to do that is just going to be like subtracting 1 or something from the color. That's fine. That's an easy enough way. Yeah, the shade will be slightly different. It'll be slightly darker, ever so slightly on the blue spectrum here. But that's okay. And if color had a 0 in the blue area, then it would just roll over to FF for everything. So that's fine. But color -1, it'll be slightly different. I think it'll roll over and it'll be okay. We'll find out. Since it's unsigned, it'll probably roll over. But as long as the color is different, it doesn't matter. Then we'll fill in the boundaries, and we can call boundary fill, and it should work. And called in with our temporary point we got. Temp X, temp Y. The fill color is the color that was passed in, and the boundary color we did was color -1. And then if we want it to be a solid color and not have an outline of a different color, I'll put redraw boundaries to to correct color. So we'll just draw the triangle again, but with the color the user passed in. So we'll draw some boundaries, we'll fill in those boundaries, and then redraw them so it's all one solid color. It is extra work, and it's extra code and processing and everything, but if you want a different colored outline, you would just draw over this with a different color. You call draw triangle after fill triangle, and it would do, you know, the outline. Okay. Well, let's see if we can get that to work. Ellipse was the last, yeah. Fill triangle test. So we gotta set these up somewhere. I guess I could do it next to the ellipse, or I could do it under the triangle and move this stuff over. It doesn't matter. So let's try it at 400. This will be the top point. I'll do 300. 2, 3, so the next one, let's go down and to the right. So let me do 450 or maybe 500. And we'll go down, I don't know, 350. Now the next point I'll do to the left. I'll do 450, sure. Or I'll make it a little different, 420. Blaze it. And V2 will be, do 250, just to be a little different. We'll do a scalene triangle, hopefully. Fill triangle solid, P0, P1, P2. I want to fill it with some fancy color. Well, let's do like let's do a purple. Let's do like deep purple. 6315 FD. 6315 FD. Let's do that. Some sort of purple. All right. Dark purple. And it's 13 sectors now. Yeah, eventually I'll change the build process a little bit, or the code, to not need to do this. Kernel's 13, 19 sectors. 16 plus 3, okay. Oh, there we go. Look at that, purple filled in triangle. So I went down here, and then I went down, and then back up. Nice. So I drawed an outline, and then filled it in, and then drew over the outline. Okay. So now I'll do filled versions of, I guess, the rectangle, polygon, circle, and ellipse. I'll just put them all down here, I guess. Fill triangle. That is right? Just make sure. This goes 100. And it goes back 80. Oh, actually, no. This goes to the left. And then to the right 20. Oh, so this goes to the left. Yeah. I wanted that to go to the right and then to the left. But that's fine. I mean, it showed it was right. Okay. It was just a little different than what I thought. So I want to make a fill rectangle as well. Just to show. Fill rectangle with a solid color. We could do some of these a different way as well. Yeah, we'll pass into 2 points. However, we did draw rect, which was top left, bottom right. And then the color. So we could do it like this, get some point within this, and then call, draw boundary, call, and do this. We could do that again. Or we could do a full brute force method. I'll do this brute force method, and that's just drawing basically what we did for the red square for the draw pixel test. It's basically what we're going to do here. So for y equal top left y, y less than, bottom right y, y plus plus, same thing for x, y less than bottom right x, x plus plus. We're going to call draw pixel for the x, the y, and the color values. So that'll fill in, you know, a rectangle of all the pixels. So we don't have to draw an outline, flood fill, and then outline again. We'll just draw the pixels directly. And that'll be simple enough. What do we want this to be? I'll have it next to the triangle, which goes to 400, so we'll do 350. And the bottom right, make it 200 long, and we'll go down 50, 350. P0, P1, what color? Let's get another color, another cutter. We'll do whatever this is, some sort of aquamarine-ish color, or sea color somewhere. 15FDCD, or maybe it's like toothpaste, I don't know. Sort of minty. 15FDCD. FDCD, okay. Mintish, greenish. Mintish greenish. Oh, and I put a thing there. I put a comma that should not have been put there. Get rid of that. Oh, I did it wrong again, redefinition. That doesn't need to be a comma, it needs to be a colon. What else did I F up? Nothing? No. One more thing. No member named Y. Yeah, that's because it's... Oh, was that in the kernel? Kernel 308. Needs to be uppercase. Small syntax errors. Always let you know you're human. And it's 14 now. Maybe I should make the kernel 15 sec. No, let's just make it 14. If there was a way to pad out within C, I would do that, but I don't think there's a good easy way to do that. Unfortunately, so I have to go through and mess up typing a 3 too many times. 3, because it's 16 plus 4, which is 20 sectors now. Hopefully this works. It compiles, so that's good. Alright, what does the filled in rectangle look like? There it is. Some sort of toothpaste-like color. Okay. So now I'll go to fill in polygon, and a circle, and an ellipse. Let's fill in a polygon. Fill a polygon with a solid color. Could call it fill poly. I'll call it fill polygon. Solid. It'll be similar to draw polygon, I think. Yeah, it should be similar to draw polygon, so we need an array triangle polygon here. So I'll just copy over this. Fill. Yeah, send it a vertex array. The number, the color, well, yeah, we could do that. The number and the color, it's fine. So this one, I guess we could probably find a way to brute force and get in the average and get a point within the polygon. Or I'm going to go back to doing like what I did up here. Let me just copy all this. Just copy all the triangle code. I'm going to do similar stuff. I do need brackets for the function. Those are important. So what am I doing? For a given polygon that I'm assuming this will work. I don't know if it works for all polygons, probably not. I'm hoping too much, but for any sort of general polygon, hopefully this works. I'm gonna sort of get a triangle that the polygon is made up as. So if it's like a hexagon that's, 6 points, I guess it could be made with 6 triangles or however. A square or rectangle is 4 points. You can bisect it and get 2 triangles. So assuming we get a point that's in the middle of one of the triangles that could make up this polygon, then we could use our fill function on that point, right? If we get a point inside of a triangle that is inside of this polygon, then we can use the fill function on that point, if that makes sense. So that's what I'm going to try to do. I'm assuming this works. So I'm going to put, assuming this works in general. I'm going to get the center of a triangle in the polygon, and I'm just going to use the first one here. So the vertex array, the first triangle in the array, the first point in the array. So vertex array 0. We'll get the x value. We'll get the x value from the first 3 points. So I'm assuming you're calling this function with at least 3 points. Hopefully you are. If you're not, well, it's your fault. Or my fault when I mess up in the future. But right now we're assuming it's going to be correct, because that's the easy way to do things. So we do that. And then this needs to be y. Let's find x. What was it? Semicolon, right? Yeah. Lowercase f, capital X to get it within the line, and then I changed it, and then I did semicolon to get the next. So colon, or comma and semicolon move between, things if you use F. I'm learning Vim, anyway. So I'm getting a point within the first triangle within the polygon, getting the center of the first triangle within the polygon. I'm assuming that'll work. But what I'm going to do is, draw that triangle. Well, no, I'm going to draw the polygon, actually. First draw the polygon sides, which will be the vertex array. It'll be the number that was passed in, and it'll be the color, but we want it to be a different color, so we'll do -1. Then we'll do boundary fill with the temp, which is the middle of that triangle we found within the polygon. Send it the color we want to fill it in as, and the boundary color, which is going to be color -1. And then we're going to redraw with the correct color. Nope, get rid of that line, which will be the same thing, but with the color. Okay, hopefully that works. That'll fill in some polygon. We'll see. Our normal ones, like a hexagon or whatever, it should work, but I want to get rect. Yeah, okay. We'll just try it on like a hexagon example again. That's fine, because I already did that. Where am I drawing this? Well, let's do all this. Fill it in under here. So this ultimate x value is -150. So I want the left of the hexagon to be at least at -100. Yeah, so that'll be okay. But the y value, or +350. That's the ultimate left point of this hexagon. Or the leftmost point, rather. Not left point. Hexagon, okay. That's the ultimate leftmost point, which will connect to the top. So let's do something like 300 -50, sure. And we'll go over 50, which would be in the middle. And we'll go to the right. So we'll say 50, and that'll be fine. This will be +50. And I'll go, I guess I'll go down. Well, this is down at 350. We don't want to go all the way up, that'd be a lot. 250. Then this can go down to 300. So the top left point, the top right point, the x's are the same, so it'll be, or the y's need to be the same rather, so it'll be a horizontal line. Then we want to go to the rightmost point, which will be 300. The x will increase, we'll say to 100. Then we want to go back down. again to 350. And this will go back to 50. Back, and then we want to go left, so the y's will stay the same. The x will go back to the middle, that's fine. And then this will be negative 50. If we want to do it like this. Or no, that'll be the leftmost point. That needs to be negative 100, yeah. But this will go back up to 300. Okay. Anyway, hopefully that draws a polygon. A hexagon in this case. Hopefully that draws a hexagon. What's some other weird color we can do? Orange. A lighter orange. FD9B15. Just being different here for the sake of being different. Still 14 sectors, that's good. Did not fill it in, but I think I just did draw, so that's why. But that's what it looks like. That's a polygon that only a mother could love. We could try to straighten that out. It needs to be fill. So this needs to be sort of the same as the first one. Yeah, minus 50. Okay, that should be a little bit better. You want to say hi? Just looking at me. She's looking at me like, what are you talking about? There we go. That's more equal. Hexagon there. So now I'll do a circle and an ellipse. Yeah, I'll do a circle and the ellipse, and then I'll probably end it because I'm tired. I need to probably eat dinner and sleep a lot again tonight. Okay, void fill circle. You don't want to hear me just complain about being tired all day, although that's kind of what being an adult is like, is just being tired all day. So fill circle, solid. Given the center of the circle, the radius, and the color we want to do. Similar to the rectangle that we filled in with a solid color, we could do this same thing again, get a point and call these 3, or we can fill in the pixels directly, sort of like what we did up here. It'll look slightly different though, because the circle is slightly different. So again, I'm going to call it the brute force method of just filling in all the pixels within an area, just to be different. I'll move this up a little bit so you can see it better. Brute force method. These will be integers though. So int 16y, we're going to do a negative radius. It's going to go to the positive radius, equaling the positive radius. Otherwise, if we just do less than, there will be a 1 pixel gap, so I'm doing an equal for that reason. In this case, didn't like that white space there. Y++. Let's have x equal, I think it's the same thing, right? Yeah. X equal negative radius, less than or equal to radius, x++. And then I'm going to put in a check. If x squared plus y squared is less than radius squared, so radius times radius, minus a radius, x squared, y squared added together, if that's less than radius squared minus radius, then we want to fill in the pixel. So I'll call draw pixel, or I can fill it in with the frame buffer. I'll just call it draw pixel. Draw pixel with center x plus x, center y plus y, and color. Yeah. So negative to positive radius for x and y, so I guess it'll start at negative x, negative y, so somewhere down there, and then just draw in, you know, the x row and the y rows to fill in the circle. I guess bottom up is what this is doing, but yeah, that's what it's doing. If it's within the circle, draw the pixel. So fill polygon, let's do fill circle test. put it next to the hexagon. So I'll have our center point be located at, where's the rightmost point here? Be 2, so plus 100, so we'll do plus 150. 1920 divided by 2, or 160, 150. Or well, we want it to be the center. Let's do plus 200, and we'll make the radius 50. Putting this here so I don't forget. 50, and then whatever color we want to do. Oh, I didn't fill this in. Light orangey. We'll put it up a little bit. 270. Put it up 30 pixels. Alright, what color we want to go with today? Pink? Magenta? Fuchsia? Something like that? Some deep sort of pinkish, magentish thing? FFOFE6. E6, magentish, fuchsish. That's a word. Oh, but I didn't put that in. Remember your colors are UN32s. Come on, guy. Come on, video man. Why aren't you smart? Come on. You're just copy and pasting from books. Even Stack Overflow. What is wrong with you? Be a better programmer. Fill in your circle like that. Look at that. My mouse is being weird. But here's the circle. I'm going to draw an ellipse like over here next to it. Hopefully. And then we'll be done. Phil Collins an ellipse with the solid color. With the solid color. This one we'll do similar to the other things. Boundary fill with the borders. We'll try that. We'll get the center point of the ellipse, the x and y radiuses, radii. Radius x, you went 16, yeah. Radius x, radius y, and the color we want to do. So first draw boundaries. Different color, so we can draw ellipse with our points, with our everything that was passed in. Surely center, radius, x, y, and color. Yeah, there we go. Center, radius, x, radius, radius y, color. We want it to be slightly different, so we'll do -1. And fill in the boundaries. So we'll call boundary fill. Center, since we're given the center of the ellipse, we can just fill it in with the center. So the circle, I could have done this too. It depends whether you like, doing this or doing this. You can basically do it for either one, I think. But anyway, since we're passing in the center of the shape we want to fill, we can just use that point for boundary fill. And the color. And then redraw the boundaries. Simple enough. Alright. And redraw boundaries as the correct color. Hopefully that's good. Did I mess that up? Oh, I did. I'm never gonna remember to put UN30. I really should make it a type def because I'm not going to remember this. I keep forgetting it. Too few arguments. Expected 4. Oh, wow. Oh, you want the boundary color. Oh, I'm sorry. There you go. You need to have the boundary color for boundary fill. Fill color and boundary color. There we go. That compiles. Now the kernel's 15 sectors as well. That's okay. Fill ellipse? No. Circle. Fill ellipse test. Okay, let's put this over and a little bit down because the drawn circle was a little bit down. So this will be over I'll do 300. And I'll just do 300, 300. 300, 3. We'll have a radius. 300, 350 maybe? Sure, and then a radius, a Y radius of 50. I can try that. So we'll pass in P0. X radius, let's do 100. So let's move this over actually. Let's move this to 350. So this will go to 250. Oh, that'll touch. Let's do 400. Okay. X radius, let's do 100. Y radius, we'll do 50. Color, we need something special. We need something special here. Yellow. Gold. FFEE0F. Hopefully that's special enough. Special enough for me not to remember. EE, FFEE, F5FOFUM 0F. Okay. I love gold. His golden wedding tackle, his golden twig and berries. You know, I like Austin Powers. So let's see if that draws any ellipse or not. We do have 15 sectors, so we do have to keep that in mind. This should be the last time in this episode I have to increase the kernel size. Maybe I'll change the build process or the boot sector next episode to not have to change all these things. We'll see. If I get really annoyed by it, I probably will. Because rage-driven development is the best kind of development. When you get so PO'd at something, you make it better. That's great. Everyone loves doing that. And it would automate it even more. There we go. Well, it's, you know, it probably should be a little darker. It's yellow. It's a piss stain. That's okay. You can see the ellipse. No, okay. So that's our drawn primitives and our filled in primitives. I should make these lines shorter because it touches, but you know, there we go. That's, you know, basic 2D graphics primitives. Hopefully you learned something or it was interesting in the least bit. If not, that's fine though. But yeah, thank you for watching. If you got this far or you skipped to this point, no problem. The next time I'll do something. If you have any suggestions, let me know. Otherwise, maybe I'll do a paint application using these things, or I'll fix up the editor some more or some other stuff. We'll see. I'll find something to do, of course. But thank you. I really do appreciate it. Thank you for watching. I will see you on the next one.